So today you guys are going to take a look at transformations of functions. So the idea here is we're going to be able to describe transformations made by analyzing the equation of any function, and we're going to be able to create the equation of the function given the descriptions. We have done this already. We have done this, if I'm looking at this, we've done this in terms of a trig function. So the idea here is here's my parent function, y equals sine x. We are able to describe what's going on here. Now, we're not going to talk about period, amplitude, that our equation of axis. We're going to talk about in terms of the vertical stretch, vertical shift, horizontal compression, horizontal shift, and any reflections. So what I would like you to do is take 30 seconds and hit pause and try to write down all those things that you know from this. So hit pause now, and we will come back and debrief on that. So hopefully you wrote down that the stretch was a factor of 3, and that came from the number out front. We had a stretch by a factor of, or a horizontal shift up 5, and that came from that piece. We had horizontal compression of 2, so that told us that piece, and and we were shifting right 30 degrees. So that's something that we have learned already, and we know those locations. Anything that affects the horizontal position is going to be inside the function, so the 2 and the 30, and anything that affects vertically is going to be on the outside of the function, so that 3 and that 5. So that was what leads us to this, is that we can take any function that looks very similar to what we have above, and we can take a look at that. And the thinking for that is this A tells us that stretch factor of A. So the idea there is if it's the vertex of a quadratic, all right, that A would tell us a vertical stretch, either pulling it up or down. You could also have a reflection, vertical reflection, if this is negative. If we have a vertical shift, that's on the outside here, we're moving this up and down by D. All right, that's nothing crazy. We've seen that before with the vertex. We've seen it with the trig. And we have a compression of K. So whatever that K value is, that will tell us how far to shrink it by K. So if it's a compression of 2, the graph is going to be that skinnier. It's going to be pushed in by a factor of 2. And our shift is by C. And this is the, remember, this is the opposite direction. So that's the opposite direction. So is this anything new to us? No. How do we apply it? Very similar to the things that we've seen before. So let's turn the page and let's see what we can see. So if we were looking at this, and at any time that you want to hit pause to write down anything, that is totally fine. And we're going to talk about these parent functions down the road. So this is an absolute function, and we're going to talk about how do we sketch that. This is this quadratic. We've already talked about that. And this is a square root function. We will talk about that in the next lesson. But we're going to focus on this. So the base function for the first one is absolute value of x. So we know that we will have some sort of absolute value inside that function. So for me, if I was looking at this, I would look at this piece first. So I would look at my vertical stretch. So here I have a vertical stretch of 2. all right? So that vertical stretch of 2, if I was doing that, that would end up being there, it goes out front. And I would look at probably the vertical shift second, up 3. I know that I'm going to be out here at +3, somewhere outside that bracket. Okay? And if we were moving this right 3, all right, I would, well, first of all, I'd probably do the K value third. All right, here we have no K value, so that K value will be just 1. And then right 30, that would be the opposite direction, or opposite sign, so it would be x minus 6. Right is the other direction. So that's how we could write that. Our base function is the square root of x, or the absolute value of x. That's where these bars are. All right. All the horizontal stuff is inside that function. The vertical components are on the outside of that function. Same thing with the x squared function. Okay. I know that I'm going to have my x squared piece like that, and then we're just going to fill them in. So first piece was the vertical stretch. So I guess we did that green. All right, so our 5 end up going out here, and then down 4 would end up being up there, so let's call that red. All right. We have a compression of 3, so that would end up being there. And then you're going left 9, so this would be x plus 9. All right, so you can build those functions the way that looks. Same thing works with the square root function. All right, I'm going to have a big square root function. And what I want to do is push pause, write down what you think it is, and then come back to it. Push pause now. So if you wrote down -3, and then under the square root 2 bracket x plus 3, and here I had no vertical shift, so you could have 0, or that could go away as well. That is totally fine. All right, so that is the basis of making the equation when given the descriptions. Okay, so that's one thing that we want to feel good about. The second piece is, if I give you the equations, I should be able to describe the transformations as moving on. Well, guess what? It's the same thing. So I'm going to do it kind of the same order as what I've done here already. So that 5 there, that is a vertical stretch of 5. So that's where that piece came from. We did a vertical shift up 3. That would be that piece. And then if I was looking on the inside, that's our K. So we have a horizontal compression of 2. And since it's negative, we're going to have a horizontal reflection. And we will talk about what that looks like when we actually talk about this function, and the idea that it could be flipped. If it's opening to the right, it would flip open to the left. And we talked about that when we were doing inverse functions in the last unit. And that was the -2. And the last piece there, so we have a horizontal shift and right 4, right? Remember, it switches signs. That is it. All right, so if we can describe those in words, we're golden. Okay? And if we want to think about this, our parent function is the square root of x. So that would be the starting one. And we'll talk more about that in the next lesson. So what are some of the tricks? All right. If I'm looking at this, some people would say, hey, I can see this, my K is 4, I'm showing this left 8, but there's a problem. If I'm looking at this, all right, the K has to be factored out, just like we did with the sine and cosine functions. So if there's no brackets there, I gotta factor that out. All right, so I gotta factor that 4 out of each of those pieces. All right, other than that, same idea. Here's my vertical shift or stretch of 3. I've got my vertical shift up 1. I've got my compression, horizontal compression of 4, and here we're doing a horizontal shift left 2. So remember, it changes signs there. All right, so not too crazy. All right, so I have that there. And again, as you're watching this video, if you want to hit pause so you can take some time to write things down, that is perfectly fine. All right, so let's look at this last one. This last one, same idea. There are no brackets here. So I gotta look at that middle. Now, this is a little tricky, all right? And we talked about this idea of how do we divide out a fraction. So the idea there is if I take -5 and divide it by half, that ends up being -10. So if I take that -5 and we're dividing it by our K, the number actually becomes bigger. So this is -10. And we have a +9 here. All right, so push pause, see if you can describe your transformations and give it a go. So if I'm looking at this, this is what we found. We had a vertical stretch of 3, and we have a reflection because it's negative. We have a vertical shift up 9. We had a horizontal compression of 1/2, which just means that the idea there is instead of the unit being that length, it's going to be compressed halfway. Well, if I take that compression, it actually will be stretched by 2. And we're going to talk about what that looks like when we graph things down the road. The idea there is, there's my K of 1/2. That means this is actually stretched out by a factor of 2. And we're going to talk about that when we start sketching graphs. And then we do it right 10. So, basic idea, can I describe these transformations from this? Or, if I give you the transformations, can you make the equation? So that is the goal for today's lesson.